Hello students, we have been studying compounds. We have studied hydrochloric acid, ammonia and nitric acid, and today we are going to see sulfuric acid, which is known as the king of chemicals, a very important topic for class 10. So keep watching. The common name of sulfuric acid is oil of vitriol and the molecular formula is H2SO4. And let us calculate the molecular mass. Hydrogen, the atomic mass is 1, sulfur is 32 and oxygen is 16. So H2SO4 means 2 into 1 plus 1 into 32 plus 4 into 16. That's equal to 2 plus 32 plus 64. So that is equal to 98. So 98 is the molecular mass of sulfuric acid. Now sulfuric acid is a strong acid. It undergoes almost complete dissociation. Almost complete dissociation. Yes. It also produces a high concentration of H plus ions, which will combine with water forming hydronium ion. Sulfuric acid is also a dibasic acid. It is a dibasic acid because it has got two replaceable hydrogen ions in its molecule. So it can react with alkali sodium hydroxide forming two kinds of salts. NaOH plus H2SO4 will give NaHSO4 and water H2O. NaHSO4 is sodium hydrogen sulfate. Sodium hydrogen sulfate, which is an acid salt. See, both the hydrogens of the acid are not replaced. H2SO4, only one hydrogen is removed by the OH of the NaOH. So you get NaHSO4 and H2O. Now, it can also further react. If 2 moles of NaOH is taken, then you get Na2SO4, sodium sulfate and water. This is sodium sulfate. This is a normal salt. So, you have two types of salts formed by sulfuric acid with sodium hydroxide. So it is known as a dibasic acid. We have seen it is a very important chemical. It is a strong acid. It has a molecular mass of 98 and it's a dibasic acid, forms two types of salts with alkalis. Now we will also see that it is an important reagent. Important reagents in the laboratory and also industry. That is why it is known as the king of chemicals. So if you have everything in your laboratory, but if you don't have sulfuric acid, it cannot be called a laboratory. On the other hand, in a room, if you have sulfuric acid, it can be called a laboratory. That is the importance of sulfuric acid. So it is highly used, highly in demand in the industry and also in the laboratory. Now sulfuric acid is also a non-volatile acid. Why is it called non-volatile acid? It has a higher boiling point of 337 degrees Celsius. It does not produce its vapors at low temperatures, right? So because of non-volatile property, it can displace volatile acids from their salt. Example, sodium chloride. Sodium chloride is the salt of hydrochloric acid. So when concentrated sulfuric acid reacts with sodium chloride, below 200 degrees Celsius, you get sodium hydrogen sulfate NaHSO4 and HCl. So HCl is produced here, hydrochloric acid is liberated. Now you can, if you increase the temperature above 200 degrees centigrade, 2 moles of NaCl will react. You get Na2SO4, sodium sulfate and 2HCl. So here again hydrochloric acid is displaced. So this is non-volatile property of sulfuric acid. And this is also concentrated acid. Same way you can use KCl, potassium chloride. You get KHSO4, potassium hydrogen sulfate and hydrochloric acid or hydrogen chloride. Now less than 200 degrees Celsius. The aqueous solution of hydrogen chloride is hydrochloric acid. So we can say hydrochloric acid is liberated here. Now if you take 2 moles of KCl or concentrated HCl, the temperature is raised above 200 degrees Celsius. Above 200 degrees Celsius, you get K2SO4, potassium sulfate and 2HCl. Again, hydrochloric acid is produced. Same way, nitric acid can be displaced from its salt. Sodium nitrate. Nitrate is the salt of nitric acid. So you get NaHSO4 plus HNO3. Nitric acid vapors are produced here below 200 degrees Celsius. If you increase the temperature above 200 degrees Celsius, here you have 2NaNO3. I'm sorry, Na2SO4 is produced. Na2SO4 and 2HNO3 is produced. So nitric acid is produced here. Then you can similarly take potassium nitrate. So you get KHSO4 and HNO3. Same way, 2 moles of KNO3 can be taken, concentrated sulfuric acid. This is below 200 degrees Celsius and this is above 200 degrees Celsius. Here you get K2SO4, potassium sulfate, and 2HNO3. So this is the non-volatile nature of sulfuric acid. So this is about the properties of sulfuric acid, and you have understood sulfuric acid is a very important reagent in the laboratory. So students, I hope you understood about sulfuric acid. So you can write your comments on the questions on the comments, and also you can subscribe so that you will get to know the further videos that I will upload. You can like the channel, and also you can watch it again so that you understand it better. Thank you.